Good morning, everyone. I am Jay Adeshan. I would like to share a quote said by John Adams. Try and fail, but never fail to try.
R square divided by 4L square. 4L square equal to 1 by 4. And 1 by LC equal to what? 1. So the 1 by 4 is less than 1. Therefore, find the step response. Find step response or find I of t for t greater than or equal to 0. From this, we understand this is underdamped system. Underdamped system. Underdamped system means there will be oscillation. Oscillations will be there. Here, the response will be like this. Since it is underdamped, because R square divided by 4L square is less than 1 by LC. Therefore, it is complex conjugate. The roots are complex conjugate. Roots are complex. That's why the response will be like this. Initial current will be 0, final current also 0, but it oscillates and then settles. So in this case, what is the step response? I of t we have to find. I of t equal to what? When t is greater than or equal to 0. So 1 I of t. If you start from voltage 5 plus 5, y plus 5, rise in potential plus 5 minus I of t, since the current through this is I of t, minus 1 di by dt, di of t by dt 1, minus 1 by c, that is also 1, integral of I of t dt minus infinity to t equal to 0. From this, let us assume that IL of 0 minus equal to 0 and VC of 0 minus equal to 0. No charge in the capacitor, no current in the inductor initially. That's why if we take Laplace transform, what you will get is 5 divided by S minus I of S minus Si of S minus 1 by S I of S equal to 0, because initial conditions are 0, equal to 5 divided by S. If you take LCM as S, you will get S square plus S plus 1 multiplied by I of S equal to 5 upon S. S getting cancelled. Therefore, I of S equal to 5 divided by S square plus S plus 1. Here, the roots are complex, we know. Let us check. Minus b plus or minus square root of b square minus 4ac divided by 2a. This is negative. This is negative. That's why it is imaginary part. It has imaginary part. So it is complex conjugate, minus 0.5 plus or minus root 3 by 2. So it is complex conjugate means we have to keep this as such, and we have to find I of s equal to 5 divided by s plus s by 2, sorry, 1 by 2 whole square one by 4, 1 by 1 minus 1 by 4 equal to 3 by 4. 3 by 4, that's why this becomes root 3 divided by 2 whole square. So we know that Laplace inverse of a divided by s plus b whole square plus a square equal to e power minus bt sin at. This formula we know. Here a square is there, but here no a. Therefore, we have to write root 3 divided by 2 as a. To cancel that, we have to write 2 divided by root 3. So this part and 5 and 2 by root 3 can be taken outside. 5 and 2 by root 3 can be taken outside. The remaining thing is identical to that formula. That's why I of t equal to 10 divided by root 3 e power t by 2 sin root 3 by 2t. So from this we can understand that it is a sinusoidal signal. Sin 0, 0. Sin 0, 0. When t equal to 0, initial value is 0 because of this. E power minus t by 2 is 1. Therefore, I of 0 equal to 0. I of 0 equal to 0. I of t as t tends to infinity equal to t tends to infinity, what you will get? This never becomes 0. Sinusoidal function never becomes 0 except t equal to 0. And periodically it becomes 0. That is different. E power minus t by 2 becomes 0. Therefore, that is also 0. Or you can find here si of s, limit s tends to 0, you can substitute and find. If you multiply the numerator by s and s tends to 0, you will get 0 automatically. So always final value and initial value finding from this is better. From I of s is better. I of s equal to what? 5 divided by s square plus s plus 1. I of 0 equal to what? I of infinity equal to what? I of t limit t tends to infinity equal to limit s tends to 0 s I of s equal to 5s divided by s square s plus 1 limit s tends to 0 equal to 0. So as t tends to infinity, it becomes 0. It can be easily found. Similarly, I of 0 equal to what? I of 0 equal to limit s tends to infinity s I of s equal to limit s tends to infinity 5s upon s square plus s plus 1. This is infinity by infinity form. That's why differentiate the numerator and denominator one time by s. You will get 5 divided by 2s plus 1. Limit s tends to 0. If you substitute, it becomes 0. So this is convenient form. So always you have to use the initial value theorem and final value theorem to find I of 0 and I of t as t tends to infinity. Okay, sometimes they ask the response is current, then okay. If the response is voltage across capacitor, sometimes they will ask, find, the question may be like this. The same problem, the question may be like this. Find the VC of t for t greater than or equal to 0, or find the step response of the circuit, step response of the circuit where VC of t is the output. Response is VC of t. Sometimes they will ask like that. In that case, there is no need, there is no meaning of finding there is no meaning of finding I of t. We have to find VC of t. But we know I of s. What is I of s? I of s equal to what? 5 divided by s square plus s plus 1. VC of s equal to ZC of s. ZC of s. Impedance of the capacitor. Impedance of the capacitor we must know. For that you must remember one thing like this. Z S of R equal to R. Z L of S equal to LS. Z C of S equal to 1 by CS. This you should remember. So what is ZC of S? 1 by CS multiplied by I of S. I of S equal to 5 divided by S square plus S plus 1. This is VC of S. Sometimes if they ask VC of S, you have to find like this. So what is VC of T? VC of S we got. What is that? C equal to 1 in this case. Therefore, substitute C equal to 1, you will get 5 divided by S multiplied by S square plus S plus 1. That is the voltage across the capacitor in S domain. Time domain we have to find. Therefore, VC of S also equal to A divided by S plus BS plus C divided by S square plus S plus 1. Find the ABC. This is voltage across the capacitor. Find the ABC. Comparing the coefficient of S square, you will get comparing the coefficient of S square, you will get A plus B equal to 0. Comparing the coefficient of S, you will get A plus C equal to 0. Comparing the constant terms, only one constant term, that's why A equal to 5. Therefore, B equal to what? Minus 5. C also equal to minus 5. C also equal to minus 5. Therefore, the voltage across the capacitor VC of S equal to 5 divided by S plus, minus, both minus, that's why we can put minus 5 S plus 5 divided by s square plus s plus 1. We can write 5 outside 1 by s minus 1 upon, already we wrote this here. We wrote this s square plus s plus 1. Now we can write s plus 1 by 2, already did earlier. Whole square plus root 3 by 2 whole square. If we take Laplace inverse, you will get s plus 1. Yes, yes. S plus 1. Vc of s equal to 5 multiplied by 1 by s minus s plus 1 by 2 plus 1 by 2 whole divided by s square plus what is this? S plus 1 by 2 whole square plus root 3 by 2 whole square minus, I merged 2 steps. S plus 1 by 2, 1 by 2. So 1 is separated into 1 by 2 and 1 by 2. S plus 1 by 2. So now we can take Laplace inverse. Vc of t equal to 5 multiplied by 1 minus. Here instead of b, 1 by 2 is there. Therefore, e power minus 1 by 2 t sine cos root 3 by 2 t. Here we have to multiply this by root 3 by 2 and divide by root 3 by 2. So what you will get here is this 1 by 2 and this 2 and 2 getting cancelled. Therefore, 1 by root 3 sine root 3 by 2 t. E power minus 1 by 2. Here also. So this is Vc of t. Initial value 0 because sine 0 0, cos 0 1, e power minus 0 also 1. Therefore 1 minus 1 you will get 0. Vc of 0 equal to 0. What is Vc of this is 1, this is 1, this is 0. That's why e power 0 is 1, cos 0 1. That's why 1 minus 1 0. Therefore this is 0. Vc of t tends to infinity equal to what you will get? E power infinity is 0. Therefore 5. So the response will be looking like this. Initially it is 0. This is Vc of t. This is time. The response will be like this. This is 5 volt. Finally, it settles at 5 volt. The capacitor will be settled at 5 volt because final value is 5.